Okay, physics, this is our home weight room lab. We're going to have you go ahead and do some work at home, and we're going to work by doing a lift. So the first thing you're going to need to do is find something that you can actually lift. I did give an example of like a soup can, and that would work well. You could go ahead and just lift that up. Or you could just do it with yourself, similar to maybe what you experienced in that 9th grade science class where all you did is you went up the stairs. So you could use yourself. It's anything you have. If you actually have a set of weights at home, you could do that as well. So you're just going through and you're going to lift something. The green boxes on the sheet are what you're going to want to fill in, so make sure that you label what you're lifting. And then we need to know what the weight of that item is. Now, if you're using something like a can of soup, it does say on there how many pounds or ounces it is. You'll have to type that in, make sure you tell me what units that represents, and then you're going to do a conversion to get that into newtons. Because remember, we want this to be the weight, which is the F of G acting on it. The distance that the lift is going to happen, you can choose whatever distance you want to do. So like if you want, you could just start with the soup on the table and you just lift it straight up. You just measure then from the table to where the height is. You do not need to have the distance coming back down. You're not doing work on that object when it brings it back down. You're only doing the work on the way up. Okay? So again, you go ahead and choose that lift. If you don't have something that measures in meters, you can go ahead and record whatever it is in the units that you do have. So like if it's feet, inches, something along that line, record that distance in the units that you have to make the measurement, and then do a conversion to get it into meters. Remember that when we're doing work, we're doing the work which is a force times a distance. So we have our force and we have our distance, so you can easily calculate the joules of your work. We are going to do this to compare to Thanksgiving dinner. It's the biggest probably dinner or meal that we've had in a long time, and we just got through having it, and I want to see if you can follow the dimensional analysis to figure out how many joules that would be. Remember that the calories we talk about in food are not true calories. They are really kilocalories. So for every 1 kilocalorie, there's 1,000 calories. We kind of signify the differences by using a capital C and a lowercase c to kind of talk about it. It's an issue with people in our society and how they don't like to see that kcal as a unit that they'd have to keep track of. You'll then be able to figure out how many reps it's going to take to burn off your dinner, and you're going to do a discussion here. When we do the discussions, I want to start to use a little bit more of a claim, evidence, and reasoning format. This is something that we should have seen in previous science classes, especially in Science 9. You're going to make a claim, and then you're going to use evidence from within the lab itself to support your claim, and then you're going to use some science information to kind of give the reason why that is true. So it's follow that claim, evidence, and reasoning. I did give you an option of what you might want to talk about. You can talk about how could you go about changing the number of reps, because maybe you don't want to do that many reps to burn off the dinner. Now in part 2, we're actually going to make comparisons of horsepower, and we're going to compare this back to our snowblower. So you're going to now do the actual reps, but we're not going to have you do all of them to burn off dinner. You can just do 20 of them, okay? And then you're going to figure out the time it would take to complete one of those. So we're going to kind of divide those two numbers to get that. And we'll get then the power that it would be for 20, and then the power that it will be for 1. And you can kind of see how those powers might be a little bit different. Think in terms of, could you sustain the amount of time that it takes, or do you start to see that time increase as the number of reps increases? So that might be an interesting point to discuss at the very end of the lab. We are doing a unit conversion again. We have to get our 6 horsepower into watts so we can actually make a comparison, because power is a rate, and we're looking at the rates of change. And then finally, you'll do your discussion here at the end, and again, try to follow that claim, evidence, and reasoning. If you do have any questions, be sure to contact me, and good luck and enjoy this activity.